All right, I want to remind you informally how we think of a function in this class and in how you thought of it in the past. This is not an official definition. We'll go over the official definition later on. A function is an equation of the form y equals some formula in terms of x. Remember that? As long as any particular x value yields a single y value. So here's the notation you've seen in the past. Y equals f parentheses x. How do you say that? Y equals f of x, and it's understood then that x stands for an input. So a function is a set of inputs and outputs. So you have an input, and for any particular input, you get a single output. Otherwise, it's not a function. Now, two different inputs can go to the same output. That's not a problem. It can still be a function. But one input's going to go to one output. Okay, so you can think of it as a set of ordered pairs, x comma y. Those are, the x is the first coordinate input, second coordinate output. Okay. So it actually doesn't have to be a formula then. Y equals some formula in terms of x. It's just that's how you're used to thinking of it. It can be just written as a set of ordered pairs or a table of ordered pairs, right? Like a t-chart. So what are some famous functions that you're familiar with? Y equals, say, x squared. Y equals the square root of, I don't know, x minus 2. Those are both formulas. Y equals a formula in terms of x, right? Now, oftentimes we replace y with function notation. So f of x equals the square root of x minus 2, or g of x. So f parentheses x, you say it as f, not f times x. We're not talking multiplication here. F parentheses x, f of x. So that if you wanted to find, what the notation means is, if you want to plug in, say, 4 for x, or let's plug in 6 for x. If you wanted to plug in 6 for x, you would say, find f of 6. 6 is the input, and then the output's going to be given by plugging 6 in for x in the formula, and then computing what it equals. So the output is 2 for an input of 6. Does that look familiar? It should look very familiar to you. Okay. So function. Now, does a function have to be defined using a formula? Absolutely not. A function is a special set of ordered pairs. But for now, just think of it as a formula. It's really inputs and outputs. Here the input is 6, the output is 2. So here we go. 2 ships leave the same port at the same time. One is traveling north at 10 miles per hour, and the other goes east at 12 miles per hour. Write a function that gives the distance between the ships after x hours. What should we probably do? Draw a picture. Good. So we go north. Usually we represent that as the upward direction, right? And then, okay, so what's the story there? The ship leaves, 2 ships leave the same port at the same time. The one traveling north is going 10 miles per hour. Oh, that's not a distance, is it? But we are given that they're traveling for x hours. So in terms of x, what's the distance that the first ship travels north? Yeah, remember the formula, distance equals rate times time? So this 10 is a rate, and this x is a time value, right? So what I'm drawing here is one leg of a right triangle. So if this is the port, then the length of this leg just represents the distance traveled in x hours. And so that's going to be 10 times x. So that's how I'm going to label it. Distance equals rate times time. Does that make sense? Okay. Now I'm going to do the same thing. So this is the position of ship 1 after x hours. Ship 1 after x hours. Okay, now I'm going to draw the position of ship 2 after x hours, and that ship is going east, right? So a little bit further because that ship's going faster. Not that your picture has to be realistic to get the answer, but it doesn't hurt to get in the habit of being somewhat realistic, making this side longer than the other side. So this is where ship 2 is after X hours. What's the length of that other? It's going to be the other leg of a right triangle. What's the length of that leg? Well, yeah, that ship's going 12 miles per hour for X hours. Rate times time, 12x. So the distance, the shortest distance between them would be the hypotenuse, yeah. We could call that d for distance. I'm going to use lowercase d, not to be confused with the d from that formula, right? So that's really instead of c, and Lewis using c, that's the length of the hypotenuse, right? So what's the relationship between d, 10x, and 12x, assuming that this is a right angle right there?
10x squared plus 12x squared equals d squared.
Now, is this written correctly? And you know what? I'll put d on the left. What's wrong with the way I wrote this? Well, no, it is x hours both ways. So that's okay. But, yeah, 10x is not in parentheses, 12x. So you're squaring the distance. The entire distance is 10 times x, so you have to put parentheses around it and square it. Even if you mean squaring both of them and you don't write down the parentheses, it's confusing. So try and get in the habit of doing that. Okay, and now it just says, it says right, oh, and by the way, what is that on the left? It's not d, it's d squared. It's Pythagorean theorem, right? Does everybody see that's all I used? Okay. So then it says write the distance, which is our lowercase d, in terms of x, essentially. So we've got it, except we've got d squared. So what do we have to do? Okay, but yeah, before we take the square root, can we simplify the right side? Yeah. So what would 10x squared be, the whole thing squared? 100x squared. What would 12x squared be? 144x squared. So you add, those are like terms. What do you get when you add them together? 244x squared. And take the square root of both sides, yeah? Plus or minus? We're still talking distance here, so no plus or minus, not yet. So we get d is equal to the square root of 244x squared. Now we probably should simplify that, right? Yeah. First of all, what can we pull out front? We can pull out the square root of x squared, which is just x, right? Because the square root splits up over multiplication. And just to remind you how to do it, maybe we should simplify the radical. So remember, you can make a factor tree. So help me out here. Two numbers that multiply together to make 244. You could divide by 2, but maybe you should try something that's a perfect square, like 16 or something. See, 4, 16. So try it on your calculator. 4 times 61. And then 61, I think, is probably prime. So if 244 equals 4 times 61, then how do we simplify the square root of 244? We could make it 2 rad 61. So I can also pull out a factor of 2, and I'll write that in front of the x and make it 2x rad 61. Yep. Do you remember how to check your answer on the numerical factors? If you just square the 2, make it 4, bring it back inside, go 4 times 61, it better be 244, right? So there's your function. What units would it be in?
Miles.
Yeah, I think it's in miles, isn't it? Well, the rate was in miles per hour, but if you find a distance from that rate, the distance has to be in miles.